Energy Matters to You podcast is a communication platform that features technologies and thought leaders working to advance energy efficiency. The Energy Matters to You podcast seek to connect buyers with sellers so that practical, cost-effective energy efficiency and sustainable energy solutions continue to gain market traction. Okay, Ron, here we go. Another Energy Matters to You podcast.
We are back.
We're rolling.
We're going to have two this month.
That's good. That's good. March 5th, 2019. So let's talk a little bit about utility incentives related to hardware. We all know that Eversource, National Grid, all the major utilities, when they provide an incentive, they like to do it related to a piece of equipment. So if somebody asked you, Ron, what are the top pieces of equipment that the utilities provide incentives for? How'd you answer that question?
Well, right at the top of the list is lighting. And then it probably goes HVAC equipment such as chillers, plate frame heat exchangers, pumps, all the ancillary type equipment associated with HVAC systems, compressed air systems, and variable speed drives. Those are probably the top as far as capital type incentives for equipment.
Yeah, and you and I over the last year and a half, 2 years probably, we've been to enough conferences where they're saying the end is near for lighting. That the big energy incentive programs related to lighting, that's it's going away.
Well, certainly we've seen some saturation in the LED market. In fact, the month of February, I think, was a bit slow for the local area program administrators as far as savings coming in. And I think a part of that might have to do with the saturation of lighting. So they're looking for additional measures, whether they're custom measures, more measures associated with data analytics, more systems types of approaches.
Yeah, but you also mentioned you led with chillers, the HVAC equipment. That chillers is a ripe area for optimization and energy efficiency and incentive dollars.
Well, that typically it's large equipment, fairly large kilowatt load. And depending on the type of facility, it can have long run hours, especially if it's associated with some type of process or biotech facility.
Yeah. And so that brings us to our guest here. We've got Mike Flaherty from tekWorx here. Mike, thanks for joining Energy Matters to You.
Happy to be with you guys today.
Now, Mike,
thanks for having me.
This your gig with tekWorx. This is not your first job, right? You've had a little experience before this.
Actually, I have. I've most of my experience, though, however, before starting up tekWorx was in the industrial automation community. Okay. So I did a lot of work with equipment for machinery for and processes in industrial automation, a lot of things in packaging, printing, automotive, and that kind of thing. So this thermodynamic, thermal energy field, though, is a bit new and the overall scope of things. But I've been doing it now for about 18 years.
Okay. All right, so what drew you? What problem did you see in the marketplace that led you to think that initiating tekWorx was a good idea?
Well, that's a very interesting story. I'll try to give you the Reader's Digest version so we don't put the listeners to sleep. I had, as I said, an automation background and had exposure to a lot of sophisticated equipment, sophisticated control technologies that are part and parcel of trying to do a good job to control processes and machines in that world. I met a fella by sort of happenstance who was deeply involved in the thermal energy world, particularly in pumping systems. He had founded a company here in Cincinnati by the name of Systicon, and they had carved out a niche for themselves to do very efficient pumping systems for big cooling production facilities. When I met him, he was telling me that he thought that there was some very, very good opportunities that existed to save money in chilled water production, but that he didn't really know anything about controls, and consequently he was not able to do that himself. And my response to him was that I had been a partner in a company that had been sold not too long before I met him, where we had a lot of control expertise, but we didn't know anything about chilled water systems. So there was a sort of a natural complement that we brought to each other. And after doing some investigation, it looked like there was a possibility to be able to bring some of these more sophisticated automation techniques from the industrial automation world to bear on the central energy plant energy performance. So that's kind of how we got going. So the idea was that he had all the process knowledge and I knew something about control. So we put our backgrounds together to start tekWorx. And as they say, the rest has been history.
So process meets controls, and you've got a mechanical engineering background. Now, there's a key stakeholder that we haven't talked about here, and that's the folks who'd actually implement, who'd run a building. So what I'm curious to know is, you got these smart guys, they know process, they know controls, they know extensive engineering. What did you hear from the end user that led you to develop what tekWorx is?
Well, the first thing that we heard was that from people that actually knew what was going on, and I might add that was a huge challenge up front, that there was a lot of folks that really didn't know what was going on, and they made a lot of assumptions about how well their operations were being controlled. But what we found was that the historical approach to designing and building chilled water systems is sort of like a lot of things. I don't know it's all terribly unique to this world. But the plan and spec approach to putting a building up and the consequent influence that has in important systems like chilled water is really just make it work. You don't bother me with the details. I just need something that's going to work. And principally because the stakeholder, the guy that has to pay the utility bill, is nowhere around during the design or the building of the building. So consequently, these systems are made more to go up, as easily as possible and to be run as easily as possible, but they're not designed to be efficient. And every place we went back at that time, they followed that approach, and every place had what we thought was a great opportunity to reduce their energy consumption by doing some things that really weren't all that revolutionary in our eyes, but they were revolutionary in the customer's eyes. So it was just an opportunity to apply some pretty standard fundamental engineering principles to a traditional approach to building these chilled water plants and make them more efficient in the process. And I think the thing that really drew me to it from a business point of view was it just seemed like they were virtually all that way. So we saw a really good opportunity in that.
Yeah. That's great. Let me bring Ron in here for a second. Mike, you just gave a great description of the fact that the building operator is nowhere around when the building's being built and in some cases commissioned or launched. You got a new guy coming in. Now, you've seen some horror stories, Ron, about people taking over buildings that had drifted far from the way they'd been initially intended to operate.
Absolutely. It depends on the type of building. A lot of these public type, bid type projects, that's classic scenario where the systems are installed and they don't work.
Right. Yeah. Yeah. Okay. So Mike, that's a great setup. So tell us, what does tekWorx do? How does it help these buildings, optimize these buildings, help these operators achieve a better managed building?
Well, we approach the client property with the idea to investigating three areas. One of them is how is the system mechanically designed and built, and the second would be how is it controlled, and then third, how is the day-to-day operation being handled. And what you find is you go back to that methodology that I mentioned before, the sort of traditional bid spec make it work approach, and you find that these systems they often have what are known as primary secondary systems. This is where you have one piping loop that's designed to create cold water and another one which is designed to deliver it out to the load. And this has been the staple, the design for a long time. And while it works, it's not very energy efficient. So there's some things you can do from a mechanical perspective to address up that system without really much surgery at all. Get the water to flow in more efficiently and more effectively where you want it. And so that's the first area. how can you make sure that the water's going in the right direction at the temperature you want, where you want, because all the software in the world isn't going to fix that problem.
Yep.
So we help them evaluate that. The second area is then giving them a control strategy, which is not the make it work type control strategy, where your goal is just don't run out of cold water on a design day, but you approach it from the standpoint that you're trying to make sure you don't run out of water, or let's just say differently, meet the design every day of the year, regardless of how hot it is or how big your load is. But you want to do that in a way that's efficient, and in fact, frankly, the most efficient way possible. So there's some control strategies that can be employed to handle that. One that we've developed extensively over the year here because of our industrial automation background is one that's known as adaptive control, where we're making continuous changes. The control is now while the system operates without a human being getting in there and tweaking everything. So the idea is for the optimization algorithms to simply pick the most efficient combination of equipment, determine the most efficient set points for temperatures and pressures and that sort of thing, and then make sure that the building automation system that's actually physically connected to the devices receives that information and uses it to make intelligent and energy effective operational decisions. So that's the second area. And that is usually deployed by sort of bolting on, figuratively speaking, some optimization technology into the existing building management system, building automation system. And then the third area, as I mentioned, is how it's operated. A lot of times this is simply things that are being done either foolishly or carelessly, or even in good spirit of trying to do the right thing, but people just don't know what they should be doing. So a lot of times this is trying to convince operators not to do stuff they've been used to doing. It's trying to get them to understand that there are different ways to run things, we really spent a lot of time sort of disabusing them of crazy notions. I think we all know the joke about the guy that goes into the doctor and holds his arm up and kind of wiggles and says, "Doc, it hurts when I do that." And the doctor looks at him and says, "Well, then don't do that." Yeah. So we see a lot of that in the systems that we get involved in, where people just need to change their behavior on a day-to-day basis, and if they do that and really effectively kind of stay out of the way from what we're trying to tell them and what we're trying to do for them, they'll get a much better result. So those are the three areas: the making some mechanical adjustments if necessary, making some control strategy changes, and then trying to get some local behaviors to change.
Perfect. Good. So, Mike, it makes a lot of sense. The design approach, and then the adaptive controls, and then fixing the operations. But I don't imagine that every building, every campus is a good fit for what you're doing based on, how much can be saved, the types of equipment. So tell us, who's a good prospect? What kind of building, what kind of issue, what kind of spend makes for a good tekWorx client?
Yeah. Well, that's a good point, Leo. We can always save people something. The only question is whether we can save them enough that it's worth them to get involved in commissioning a project and going through it. Generally speaking, this approach that we employ can save somebody around 1/4 of a kilowatt per ton hour, somewhere between 0.2 and 0.4 kilowatts per ton hour. And if you multiply that times the energy that you use to do your cooling, and then the cost per unit of energy in a place like New England, where you're paying 14, 15, 16 cents a kilowatt hour, you can usually be effective down to plants that have maybe 400 or 500 tons of installed production. A little better metric, if you've got the wherewithal to figure it out, is to figure out how many ton hours you have, which is more or less what your average load is times the number of hours that you run throughout the year. If you can come up with those two metrics and multiply them together, and you get a number something around 1.5 million or 2 million, you usually can figure out a project's going to work. So that's the rule of thumb we try to give people: about 500 tons installed capacity or greater. And of course, the longer your system operates, for example, a hospital or a process, then the smaller that plant can be, or the further south it gets, where the load's higher. Of course, that's not going to do you much good up there in New England. But the point is, you do pay a lot of money for electricity relative to a lot of areas in the United States. So those metrics should hold up pretty good.
Yeah. That's really helpful guidance. And obviously the gross numbers apply to any kind of facility, but you'd called out hospitals. And I'm wondering, if a facility meets the 400 to 500 tons of installed capacity, is there a type of facility that's better or worse in terms of receiving the benefits of tekWorx approach?
I'm sorry, Leo, do you mean in terms of the type of facility, whether it's a hospital or a courthouse or something like that?
Exactly. Yep.
Well, not particularly. The net effect of that difference between one type of facility and another typically is just how much they have to run their chill water plant. If you have an office building in New England, it's not going to use much mechanical cooling between 1st of November and 1st of April, and it's probably not going to make much on the weekends. So, your runtime hours are down there. But if you've got a hospital or something like that, which has people in it all the time and which has high loads, operating rooms running all year long, where they're making cooling all year long, and of course that helps. Data centers are another one. Of course, they have pretty good loads regardless of the time of year because they're not weather dependent. And then some manufacturing processes. We've done quite a bit of work with both automotive, pharmaceutical applications, R&D, vivariums, production facilities, that sort of thing, where they need cooling all the time, regardless of the weather. So those are the main issues that drive it.
Yeah, perfect. Hey, Mike, I noticed at your website that you've got over 250 installs and $1 billion or more of savings. Can you tell us a little bit about those installs? Where are they geographically?
Most of our installations are in the United States. We have done them internationally in South America and Asia and Europe. That's a relatively modest amount because we don't actively market there. The reason we're in those foreign locations is because we do a lot of work with U.S. companies that happen to have those locations. Okay. And those companies have a tendency to be either located in the the northeastern quadrant of the United States because of the utility cost, or the southern part of the United States because of the temperature profiles, or they are located virtually anywhere because they just have a really high cooling demand, such as we do live work with automotive companies for paint shop applications and things of that nature, where they got a lot of cooling all year long. But generally speaking, the things that drive the applicability of our system and the payback are going to be one, the utility costs. You have a pretty high cost in New England relative to, for example, what we pay down here in Cincinnati. Two, the amount of cooling that you have to produce. Again, that's driven either by the length of your cooling system or just the size of your load. And then the third thing is how much attention somebody's paid to keeping the plant in good working condition in the first place. Or a nice way to put it is what I just said. We usually say it depends on how screwed up it is. But if nobody's paying attention and the equipment's not really being well cared for, people aren't watching, don't know what they're doing, you'll save a lot of money, half a kilowatt per ton we've seen. If somebody's done a reasonable job and at least trying to keep their eye on it, you could still wind up saving a couple of tenths or kilowatts per ton. One thing I think is interesting that I find is people think that just because a system is relatively new that it can't be optimized. Or they tell me that because they get their chillers checked all the time that they really don't have any room for this. But it all starts back to the first part of the discussion we were having. If the system isn't designed to be efficient in the first place, and most of them aren't, it doesn't matter how old it is, You can, you can make some modest adjustments and get some pretty good savings, regardless of how old the system is, because it hasn't been designed to be efficient in the first place. And the other thing is, people will say, why they do their maintenance all the time, and they get their chiller tubes cleaned and they check this, check that. Again, that depends on how the system was designed, and the real key to optimization is, in addition to correcting those sort of design mistakes, is you have to stay after it constantly, and that's where the orchestration of the operation of all the various pieces of equipment on both the air and the central plant side are brought together so that they're working in a way that's going to give you the lowest amount of power draw per unit of cooling output.
Yeah. Good stuff, Mike. God, we try to keep these podcasts to 20 minutes, and I know we could talk for another couple of hours, so this is really helpful. Two things that I want to kind of bring to close with. One is, can you give us a little bit about your tekWorx's go-to-market strategy? How are you approaching the marketplace? Where's the access point? Clearly, you've got some traction. You've got a bunch of installs. I'm curious about that. And then the second thing is, if someone's interested in connecting with you, what's a good way to do that?
Well, I'll answer the second question first. It's very easy. I mean, we have a very nice website. It's www.tekWorx, tekworx.us. And there's quite a bit of good information. There's some documented case studies on there. There's a form you can fill out, pretty simple form you can fill out, and we could take a whack at giving you an estimate on how much money you could save and give you an idea of whether it seems like it makes sense for a project to unfold.
Hey, Mike, I want to jump in on that, because I spent some time on the website and I saw that calculate savings tool that you got. I think that's a great piece for someone just to broad brush figure out if it makes sense. So that's a time well spent if you're interested in knowing if there's opportunity there for you.
Yeah, and the key of that tool, Leo, is if we don't want to waste our time any more than we want the customer to waste theirs. So if somebody can just get in there and bang around for a few minutes, we can both be very expeditious in figuring out if it's worth it to move further.
Yeah, good stuff.
So, yeah, okay. And then the first question you asked, our go-to-market strategy. Well, generally speaking, what we've had to do over the years is basically we've been knocking on a lot of doors and looking for the people that are responsible for energy, and try to engage with them to say, do you have chill water? Done anything about fixing it up and improving its efficiency? And if so, if not, let's talk. And that's been our main go-to-market approach. Over the last years, we've tried using some intermediate parties, but we find that that's a tough sell, because most of the contractors and the integrators and so forth are a lot more reactionary. They're typically focused on the construction side of things rather than the energy efficiency side of things. So what we have been finding out is there's been some good traction recently with service contractors. These are people that do mechanical service and control service. They are aware of the condition of plants. They are aware of the mentality of the people that own and operate those plants. And we've been trying to engage more and more with those kinds of companies, because they can use something as we have. They can use our product to go to a client and say, have you ever thought about doing something to save energy, instead of just waiting for something to break and running and fixing it at that point. So they become more of a consultant, a little more proactive, and really they're selling out in front of a problem rather than waiting to solve one after the fact. So that's been a relatively recent endeavor on our part, but it is looking like it's having some traction.
Good to hear. All right, so Mike Flaherty, tekWorx, want to thank you for bringing your technology to Energy Matters to you. We learned a lot today, and wish you the best of luck moving forward.
Thank you very much, gentlemen. It's nice talking with you, and wish you good luck in your endeavors as well.
Thanks, Mike. Thanks for listening. To keep up with future podcasts, please join our LinkedIn community at Energy Matters 2U. That's Energy Matters, one word, the number 2 and the letter U. We would love to hear your comments and ideas, so please feel free to contact myself, Leo Ryan, or Ron Galuli through our LinkedIn profiles. There's work to be done. Go make a difference.